Summary measures. Measures of dispersion. Measures of dispersion are also called the measures of variability. It indicates the extent to which observations in the data differ from the average value. From the root word disperse or scatter, it is how the observations are scattered. It is how close or how far apart each observation are from each other, and to the mean in particular. We have here a simple illustration. Image A on the left is more dispersed than the image B on the right. That is, the observations of image A are far from each other compared to the observations of image B, which are closer to each other. Let us have another illustration, but more detailed, in the next slide. We have here 3 dot plots for data sets A, B, and C. Each data set has a mean of 15.5. Where is 15.5? It is somewhere around in the middle. The values of the mean are the same. But take note, the distribution, or the distance of which observations are different. The observations in data A are scattered across the dot plot. Here, we can see values of 11, 12, 13, 16, 17, 18, and 21. While in data B, a lot of the observations are found clustered together at the 14, 15, 16, and 17 mark. Then, we have data C, which has polar opposite values with 11 and 12, and 19 and 20, as the recorded observations. Now, which among the datasets have observations closest to the value of the mean of 15.5? Will that be data A, B, or C? And the correct answer is data B. Which dataset will have observations farthest from the value of the mean 15.5? And the correct answer is data C. As you can see, they have the same mean, but the distribution, the scatter, the variation of each of the observation in each dataset is different. And because of that, we realized that we need additional tools to better describe our data. As you may notice, when we do our reports and we describe our data using our measures of central tendency, we often add other statistics to better understand and characterize our data. And for that reason, we need the measures of dispersion to describe how the observations differ from each other and are scattered away from the mean. Let us start with the 2 types of measures of dispersion: the measures of absolute dispersion and the measures of relative dispersion. The measures of absolute dispersion carry the unit of measurement of the observations just like the mean. The most common summary measures are the range and the standard deviation. The variance may be difficult to use in practice because variance is a squared quantity, and therefore its units are also squared. Example: if our variable of interest is age in years, then the unit of measurement will be age in years for the mean, range, and standard deviation. But age in years squared for the variance, making it difficult to interpret. However, we include here the variance since the formula of the standard deviation is derived from the variance. When do we use the measures of absolute dispersion? It is used to compare datasets with the same means and the same units of measurement. We will provide some examples in the succeeding slides. On the other hand, the measures of relative dispersion is unitless. And here this time, if you have 2 or more datasets with different means or different units of measurement, then you can use the measures of relative dispersion, because it does not carry the unit of measurement of any of the variable of interest. The most common summary measure of relative dispersion is the coefficient of variation denoted by CV.